In Part 3 of Lecture 2, we will discuss methods and parameters. So far, we have seen a few examples of procedures, although in Java we typically call them methods. One example is systemoutprintln, which we have used to display output on the screen. We've seen keyboard next int and keyboard next double, which we have used to get integer inputs from the keyboard. And now we've also seen new random number next int, which we have used to get random numbers. Methods have us many advantages. They allow us to use software routines that have already been written, frequently by other people, and we can use them in our programs. For example, magic equals new random number dot next int. It also, as we will see later, allows us to make our programs easier to organize and easier to read and easier to work with. And that's something that we'll see over the course of the semester. Once we start talking about methods, we need to talk about parameters. A parameter is a value or a variable that is used to provide information to a method that is being called. So for example, if we are writing a method to calculate the square of a number, we can pass the value to be squared as a parameter, as you see here. Print square 5 or print square x. I can use it for a literal value, or I can use a variable. These are called actual parameters because these are the actual values or the actual variables that we are going to have the method used and that we are calling the method, including the name, so we can pass the information along. The methods that make use of these parameters must have them listed in the method's header. These parameters are called formal parameters. You can see in the example that when we start writing the header for the method that we're calling, as we've seen it before, we begin public static void print square, but in parentheses what we have there is double x. The value that we're passing is known within this function, within this method, as x. Its type is a double. You'll notice in the method we have its own local variable, double square. Square is going to be a double precision float. In here you can see we calculate square by multiplying x by itself and then print it. X, as you see it here, is called a formal parameter because we are formally defining it here. The way we communicate values between the method that is doing the calling and the method that is being called is called parameter passing. You see at the top of the slide two instances of print square being called. In the first, we are passing it the value 5, and in the second, passing it the value of the variable x, whatever value we assigned to it earlier. These values get copied over into memory set aside for the method print square. That value can then be used to calculate the square and to print it out. In this first example, I have written print square 5, and that is a statement being executed. The value of 5 is passed into the memory space set aside for x in a memory belonging to the method. It will then multiply x times x, which is 5 times 5 equals 25. And the value it will print out is the square of 5 is 25. Now, we'll execute the next statement, print square x. Whatever value we are holding in x in the method that is doing the calling is passed over to x in the method being called, namely print square. If that value is 12, x, as we begin to execute print square, is equal to 12. I will calculate x times x, which is 12 times 12 equals 144. And I will print out this time the square of 12 is 144. The program you see here illustrates how we make use of other methods that we call. We begin as usual with import Java util scanner, and then I write a header for the class, public class squares, and an open brace to begin the class. I write a comment for the main program, main, a driver for the print square function, and then I have the header for the main method, public static void main string args, and now I have an open brace for the method. Scanner keyboard equals new scanner system in, and I declare the variable double value. Now let's do the work involved here. A comment, get a value and print its square. System out println, enter a value. Value equals keyboard dot next double. And lastly, print square value. Value in this case is the actual parameter, the actual value that we are going to pass to the method being called. Here you see the print square method. I begin with a comment. Print square prints the square of whatever value that it is given. Every method in a class should have a comment describing what the specific method does. I now have the method's header. Public static void print square, and in parentheses double x. Double x, as you see here, is the formal parameter, and it is being passed the value from the actual parameter in main. You'll see now I have double square. Square equals x times x. And lastly in here, system out println, quote, the square of, unquote, plus x, plus, quote, is, unquote, plus square, close parenthesis, semicolon. I have a close brace for this second method, and a close brace for the class. This diagram illustrates what we have going on in the program. There are two areas of memory that we're looking at here. The one on the left is the memory that belongs to the main method, and on the right is the area of memory set aside for the method that we are calling, printx. Value, which in this case is 12, is copied over into the space set aside for the method printx, and that's how it gets over there. From this, we will now calculate the square, which will be 144. In this example, value now has the value of 6. It is that value of 6 that gets passed to print square. We then calculate the square of 6, which is 36, and that is what print square will end up printing out. We are now going to write a new class called squares2. It will have the same version of print square as before, but the main method will be different. The main method begins with a comment, a driver for the print square meth function. We now have the header for the function, public static void main string args, and we have an open brace to begin this. You'll notice now I have two values. Double value 1 equals 45, value 2 equals 25. And you'll see here in the same method, I will call print square value 1 and print square value 2. I will call the same method twice in a row with two different actual parameters. What this is all about showing is that the names in the method that is being called and the names of the values in the method that is doing the calling can be different. The two diagrams that you see on the slide will show us how the two different method calls will work. In the first case, it is value 1 that I make use of. Its value of 45 is copied over into the space in the memory set aside for the method print squares for the value x. From there, I calculate 45 squared, which is 2025, and that's the value that I'll print. In the second case, you'll notice this time it is the value of value 2 that is passed over. It's copied into the space set aside for x in the memory set aside for the method print squares. I will then calculate 25 squared, which is 625, and that is the one that I will print out. It is important to note that the actual parameter and the formal parameter can have different names. That is part of what makes it such a useful tool.